eighth lecture 8th of the electrostatics. In this lecture we are going to discuss about electric dipole. And what is electric dipole? The electric dipole consists of the pair of equal and opposite charges. It consists of pair of equal and opposite charges. The charges are equal and opposite, and they are separated by a small distance. This is known as electric dipole basically. And the water molecules and ammonia are the example of the electric dipole, because in these molecules the center of the negative charge and the positive charge are separated by some distance. Yes, because let me make the shape of the water molecule. Water molecule look like this, something tetrahedron is shape, I think. And then this look like the, because the negative charge and positive charge concentration are uneven, so basically these are known as the polar molecules, and all polar molecules have the dipole moment. And similarly you can draw the ammonia also, NH3, I think it look like this also, and tetrahedron shape only. And this is also uneven in the shape, and basically these are the polar molecule, and all polar molecule have the electric dipole moment. Similarly you can check it for the CO2. This is non-polar, means it is symmetrical. If you check the configuration, let's see, O and O, it is symmetrically. So all the basically then it is symmetrical, then it is the charge distribution is not uneven basically, then it is not behave like a dipole. And what is dipole moment? The dipole moment is the measurement of the strength of the dipole we are talking about, and it is the just the product of the magnitude of either of the two charges and the distance between them. Let me take the two equal and opposite charges, opposite in the sign, and positive and negative charge, and they are separated by, let's suppose they are separated by 2a distance. And then the magnetic dipole moment, yeah, strength, is represented by, we write the dipole moment as p vector, and simply this is the product into the one charge. The we simply take the magnitude of the one charge and simply the distance between them. In the these represent the dipole moment between the charges. And ideal dipole is the dipole in which ideal dipole the dipole in which the 2a distance is very less than a. Then we simply say that when the dipole behave like a point charge, when a dipole behave like a point charge, dipole moment have the its particular direction. It is opposite to the electric field direction basically. It is opposite to the electric field direction. It is from the negative to positive. Dipole moment direction is negative to positive. It is a vector quantity. It is a vector quantity basically. And negative. The next topic is electric field intensity due to the dipole at its axial line. at its axial line. For this we consider that let's suppose I have the dipole positive and negative. Let me consider the charge here positive, and the axial position, let me make that, this is the at the negative charge here, and this is the positive charge. We simply represent it by the positive q, and distance between them is 2, the distance between them is 2a. And let assume that we are going to find out the electric field at p point, and then we have to assume the distance from the, this is the basically this is, you can take at origin also, and from this point to the this we are taking the r distance, and basically then it become a, and this also become a, and then from this configuration, keep in mind this configuration, and we are going to deal with it. And I now due to the positive charge here on the p, electric field direction is away from, yes, because the electric field goes away from the positive charge, and this is the e positive value, and this is the e negative value. Remember that e positive value I should write smaller, because electric field due to the point charge is nothing but 1 by 4 pi epsilon naught and q by r square. If the distance from the positive charge to the p is large than the distance from the negative charge, so the electric field due to the positive is less. So I should represent it by the small vector. It is e positive and e negative is greater basically. And then let me assume that the electric field due to the positive charge, we simply find out the electric field due to the positive charge is nothing but 1 by 4 pi epsilon naught, and q by distance between them. Remember that distance between the positive charge and the p is r plus a, and the square. And similarly e negative having the distance 1 by 4 pi epsilon naught q by simply, I am just taking the magnitude, not taking the direction. If I take the, let's suppose I take the negative q, and then the distance is r minus a for the negative, and simply you can look at the configuration also. The distance between the positive charge, positive q to r is r plus a, and from the negative charge this is nothing but r minus a simply, and then it come out to be uh, this is come out to be, if I am representing by the x vector, then I have to, let's suppose this is the in the x direction. I point that it is in the x direction, x unit vector. I point this direction as x unit vector, because if I have to write the in the vector form, I have to represent in the vectors also. Then I have to tell the direction. Then the, because e negative is greater than the e positive, basically we are going to deal with the magnitude only, because the direction ultimately go to the x direction only, the vector. And this, in this 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, and the q by, we are dealing with the magnitude only, remember that we are forget to square it, minus 1 by 4 pi epsilon naught, because it is simply minusing due to the positive charge, and q by r plus a the whole square. And if I solve it, take out the common 1 by 4 pi epsilon naught q, and then I think the inside remains this value, q by 1 a minus r square, then it come out to be q by 4 pi epsilon naught. Then I have to uh, let's take the whole r minus a. Can I write it in this way? The whole power square, because power can be divided, and then just I have taken the common here, then taking out the LCM, then here I think n plus a the whole square minus r minus a the whole square come out to be, if you take the LCM, then inside use the identity inside there use the identity a minus b, a plus b is nothing but a square minus b square, use their identity inside, and then the electric field at the axis, I should write it axial come out to be q by 4 pi epsilon naught is outside, and inside I think the remaining terms, if you solve it, the remaining term is 4a r, and in the below you will get r minus a square. Using this property you will get this answer simply, and dividing if you open these squares open these square, you will some values are going to be cancelled out, and then this term on the above will remain only, and then you can write I think 2 into p r, p is nothing but we have discussed 2aq. Yes, I have just put it the p, then 1 by 4 pi epsilon naught r square minus a square by uh, this answer you are getting, and the x direction I have taken the axial direction, e axial we are getting, and then we can also take the some of the cases. Let me take the case is 2a is very less than the a r, then I ignore this a here, then one cancel out, then the e axial is coming out to be 2p 1 by 4 pi epsilon naught, and here become the r the power 4, and then r will cancel out, 1 r will cancel out, 3 power remains. Remember this result, and in the dipole case you are getting the electric axial is inversely proportional to r cube, but in the point charge you are getting the square only. Next topic is electric field intensity due to the dipole at its equatorial line. Equatorial lines, let me make first the dipole. The dipole is, let's suppose the dipole, I make the dipole negative charge, simple, and the positive charge, and negative charge and the positive charge, and the distance between them is 2a, and the equatorial line is the perpendicular line basically, and it is in between these two charges, and this is the a basically, and this is the a also, and let's suppose I want to find out the at this point the electric field, then the due to this negative charge the electric field direction is in this direction, I name it e negative, and due to the positive charge the line joining them the electric field direction is line joining them in the outward, because due to the positive, it is outward, E positive, and then the resultant look like this. The resultant look like this, somewhat I name it as a ER, and let me take some of the this is the some R, and let me take this as also R, because they are the equatorial axis. Then the both they are at the same point, and sorry, we have to take the R distance from the axial. Okay, from this center point we have to take the R value, and in the previous also in the previous case, we have find out the electric field in the axial. We have taken the R from the center only. Okay, and then this value is come out to be, using the Pythagoras theorem, this value are come to be R square plus A square, and then this value is again is equal to R square plus A square only, and because we need the this distance between the point, this point, and the this charge to find out the electric field, then let me take the electric field E positive. Then the E positive value is come out to be 1 by 4 pi epsilon naught q, and by R plus A the whole square. It is nothing but if we it is R square A square the whole square. Basically whole square will cancel out with the under root, and then it come out to be this value only, and then the E negative is 1 by 4 pi epsilon naught, and minus q by R square plus A square, and then because these both have the equal magnitude, E positive is equal to the magnitude is equal to E negative, and basically these both are having the magnitude is equal to q r square plus A square. Yes, and then if you find out the resultant magnitude, then for this we are going to take let me go to the next. Let me take this as a theta. Let me take this as a theta, and then this come out to be 90 minus theta, and then you can directly say that this is theta, because this is also parallel to this line, corresponding angles, and then this is also theta because due to the symmetry, because E positive is equal to the E negative, then the angle between the E positive and E negative is nothing but 2 theta. Yes, and then I simply write the equation ER magnitude is come out to be here. Let me take the under root E positive square plus E negative square, and E 2E plus E minus cos 2 theta. Yes, and then you have to some use of the trigonometry also. Be careful in it while dealing with it. The magnitude are equal, then you can take E square plus E square plus 2E square, and the cos 2 theta, by dealing this one, what you have to do first, take it as a cos 2 theta only, and then take out the, you can write that 2E square theta 2E square. You can take out the, it is better to take out the 2E square common, then 1 plus cos 2 theta. 1 plus 2 cos theta is 2, 1 minus 1 plus cos 2 theta, yes. And then I think then you can use the identity e square is equal to under root 2 1 plus cos 2 theta. Cos 2 theta formula is I think 2 cos square theta minus 1. Then if you take out the negative 1 here, then it is 2 cos theta is equal to 2 cos square theta, and then it come out to be the under root, then value is 4 sorry 2 come out, then e and cos theta come out, then this value become this. And then after putting these all the values of the cos theta and cos theta value come out to be uh, base by hypotenuse, and base by hypotenuse a by a square, and then we will move further. This value is come out to be, if we value put the value the e here, then we are getting 2 1 by 4 pi epsilon naught q by r. We have taken the value as a plus r square, and the cos theta value is a and under root a square plus r square. Then it come out to be 2aq is become the p, and then 4 pi epsilon naught, and this come out to be a square plus a square the power here 1, and then right now there is 1 plus 1 by 2 power, then it become 3 by 2 power, it becomes the 3 by 2 power, and that's simple it is. And that's it for this. And we have find out the electric field at the equatorial, and if we take the vector quantity as p is act as a vector quantity. That's it.